Hi everyone, it's Sorkin. Today we have a problem when we need to multiply two sparse vectors. So what is a vector? Vector is a dynamic array that can grow or shrink in size as needed. So for example, let's take the first example. Let's take a dense vector. What's a dense vector? A dense vector is a vector where we have most of the elements in the arrays are zeros. And also we have a sparse vector. In the sparse vector, we are storing only the key and the value. We are storing the index where we have non-zero elements. So how we are going to solve this problem? In our case, so what we are going to do is, the first step, we are going to create a sparse vector from a dense vector using hash table. So either hash map in Java or dictionary in Python. So what we are going to do is, so for example, let's say that we have dense vector of 0, 0, 5, and so on, and we are creating a hash table where we have a key value. At the index 2 we have 5, value of 5. At the index 6 we have 4. At the index 11 we have 19. So let's take another dense vector, so 0, 0, 7, and so on. So again, we are doing the same. We are creating for non-zero elements. So we are, in our hash table, we are storing a key as an index and the value as our non-zero element values. So, and the next step, what we do is we are going over hash table and the multiplying values. So for example, there is no need to multiply the indexes where we have both elements of 0, or if the one element is 0 and another one is non-zero, so the result would be 0 anyway. So we are multiplying only those cases where for both we have the non-zero elements in the dense index. So for example, in our case, for the 2, in the first dense index, first the dense vector, we have value of 5, and for the second we have 7, right? So we are multiplying 7 to 5, and the next step is that, so for the 6 of the first dense vector, and for the 6 of the second dense vector, we have again values 4 and 11. We are multiplying them. 11 multiplied by 4 and plus 7 multiplied by 5 gives us 79. First thing that we do, we are going over our array and we are checking that if the element in our array, if the num is not equal to 0, then we are storing the index of that element and we are storing the element itself, the value of it. So in our dot product function, so what we have, we are receiving another sparse vector that has also the dictionary. So what we do is we are going over our dictionary, and we are checking that for each index where we have non-zero element. So for each key, we are checking that do we have the same key in our another sparse vector that we are receiving in the function. So if we have, which means that at that position for both vectors we have non-zero elements. So we are multiplying that. So we are multiplying our value from our vector, and we are taking the value from the vector that we are receiving, and we are multiplying them and adding that to our result. So what's the time and space complexity of this solution? The time complexity is that we are going over our array once, so it's of n, and the space complexity is again we are storing in our dictionary. In the worst case scenario, we are going to store all elements, so it's also of n. Java solution is identical. So what we do is, first thing, we are creating a hash map, non-zero elements, where we are storing key as a index and the value we are storing that element. So, and as we initialize sparse vector, we go over our array and we are checking that if the value at that index, if that element is not 0, then we are adding the index and we are adding the value itself. And the next one, in our dot product method, so what we do, we are receiving another vector and we are going over our non-zero elements hash map, and we are checking that we are taking the index and the value, and we are checking in our vector that we are receiving, does it contain does that vector at that index have value also? It's a non-zero. If it's also non-zero, then we are taking the value then we are multiplying our value, and we are taking the value from that index, and we are adding that to our result, and at the end we are returning the result. So the time and space complexity for this solution, the time complexity is we are going over our array once, and the space complexity is, in the worst case, we are going to store all elements in our hash map. So the space complexity is of n also. Okay, that's it for today. Hope you like my content. If you like it, please hit the like button and subscribe my channel. See you next time. Bye.